So howdy, everybody. I also have an alternate title for this talk, which is Preventing Insanity. So I started at MongoDB about 3 years ago, and like starting any engineering position, you start out with a lot of education. So just like you guys, I had to go through all the MongoDB University classes. We had internal training. I had all of these quizzes. I had homework. I was spending 8 hours a day basically learning about MongoDB. And it doesn't take you very long before you start going crazy. Like, you remember from school, doing that much coursework is kind of a pain. So my boss, in his infinite wisdom, he's not here, but I'm still gonna give him props, said, you really need to get your feet wet with MongoDB. You really need to go out, build something. Start learning through experience. So I'm like, hey, I have this really cool project that I wanna work on. I have all of this data that I really think we could do something interesting with. So this is really my journey through that process. So as he said, my name is Kevin Arhelger. I'm a senior technical services engineer here at MongoDB. Been here since January 2016. I'm senior TSC. That means if you ever open a case in support for anything performance related, I probably will answer you or have my fingers in it. I'm very performance driven. I'm new to MongoDB at the time, but not software performance. I've done public facing benchmarking for decades, Java performance, worked with Intel on hardware optimizations for a very long time. So not my first rodeo, but new to databases. I really love data. I have spreadsheets figuring out where the cheapest toilet paper I can buy is. I'm also a little bit of a programming polyglot. I spent much of my career working in Java, but I really like trying to change up what languages I use to really match what problem I'm trying to solve. I have a little bit of a disclaimer here. This is my personal journey. I entered this process as a total MongoDB newbie. I made a lot of mistakes. These aren't mistakes or problems with MongoDB. It was how I was using it. So I wanted to get that out of the way ahead of time. You guys all look like really smart people. You probably won't make the mistakes I did, but I'll try and guide you a little bit to keep you along the right path. Hopefully I've improved and been a little smarter in the last 2.5 years. So what's the actual project? So a couple of years ago, February 2015, turned on this thing and started reading my water and electric meter off the side of my house. So these things are sending out what my readings are every couple of seconds to every couple of minutes. And I had just started recording this. I didn't do anything with the data, but I'm like, it's there. I want to do something with it. I'm working for a database company now. Maybe I should put this in our database. That seemed like a logical progression there. Maybe I can learn something interesting about like my usage. There are certain days where I use lots of electricity, or maybe water usage is up on the weekend. Like lots of cool insights I could learn from this data if I could actually query it, do something interesting around it. And I really wanted to get my data up on the internet. There's a lot of cool things I could do with that. Maybe if a water main broke in my basement in Minnesota, I could tell the fire department to go shut my water off before everything froze. So, lots of cool things I could do with this data. And it is a little bit of Internet of Things. These aren't natively connected to the internet, but that's kind of the layer I wanted to build. So I wanted my meters to be connected to the internet, constantly updating so I could do some cool stuff with it. So how did I make this work? So in my municipality, the utility companies have these Itron style meters. So there's the big logo down in the lower corners, highlighted in red. So these are a special kind of meter. So in my location, they have electric and water meters. They both do the same thing. They have a 900 megahertz radio, and they send out the broadcast, they broadcast the consumption, anywhere from a few seconds apiece to a few minutes. And this is really useful for the utility company Because now they can just send a truck with a big antenna on the top of it down my street and slowly drive by and just pick up the readings. They don't have to send someone in snowshoes over to go read it in the middle of winter. So these meters have radios on them sending it out, so I needed something to read all of this radio data. So I went out, did some digging on the internet, just did a couple of Google searches, found this guy called Douglas Hall. He has a GitHub project, and he's like, I want to do the same thing. So he wrote a utility. It's written in Go, so called RTL AMR. There's a link that you can find on the slides later. That uses one of these little software-defined radios. This was originally a Japanese TV receiver. A few enterprising engineers found that it was reprogrammable, so they could listen to pretty much any radio frequency they wanted to. So between this little radio receiver and this project, I could download all of the data as it was coming in live and just store it off to a file. The little exporting tool wrote out JSON, so I was already part of the way there. So I had to connect that to something. The radio has a USB port on it. I needed to connect it to a laptop or a server or something. I picked Odroid C2. It's very like a Raspberry Pi. A Raspberry Pi would work fine for this today. The performance was not quite as great when I started this years ago. So this is what the complete setup looks like. Over on the left-hand side, we have my water meter and my electric meter. They're sending out all of the data wirelessly. I have a little antenna. It's sitting right on my desk, connected to my little software-defined radio, connected to my tiny computer. It's running the software, just dumping JSON to a text file. And that's been running since 2015. So I now have a classic ETL problem. So I need to extract this from the text file, needed to do whatever manipulation to get it into MongoDB format and just dump it into MongoDB as fast as I can. It's not ETL in the traditional sense. It's not a data warehouse. Usually you're going from one database to another, but it has a lot of the same characteristics. So I'm converting between two different formats. I need to read all the data really quickly, and I need to dump it into my destination as fast as I can. So ETL, this is really the story of the ETL process. So that's all well and good. What does the data actually look like? So it's a classic third normal form, tabular schema. We've all seen millions of these before. Fields are relatively simple. We have a time, that's when the reading came in. We have an ID, so this lets me know the difference between my water meter and my electric meter. My utility company just wrote the numbers right on my bills, so I didn't even have to go outside and check. There's a type, also differentiates it between the different kinds of meters. So between an electric meter, a water meter, gas meter, etc. There's also tamper flags, so the utility company can figure out if I stuck a screwdriver in my electric meter. And if that happens, they'll send someone out to make sure I'm not baking. And then there's the consumption. That's the actual reading right off the meter. And then there's a cyclic redundancy check just to make sure that everything came in right, that they don't accidentally bill me for something that didn't happen. So that's what the data looks like. So I have most of the components here. I have my meters, I'm reading the data, I've been doing it for a while, dumping this off. So now I want to really do something with it. So I really wanted to use some simple tools. So everything I did for this is basically right on my laptop. MongoDB was on my laptop, all the load was on my laptop. A lot of people ask about that, how fast it goes to this. This was just, I wanted quick answers. I didn't want anything in my way. I also wanted to really iterate fast. I didn't know what the data would be. I didn't know if something needed to change. I didn't know how clean the data was. I didn't know if there was anything else that needed to happen. So I really wanted to spin on this really quickly. I did have a day job. I did have all of these other classes I needed to do, so I couldn't spend an unlimited amount of time on this project. And Again, I wanted to use simple tools. I really like the Unix philosophy of piping lots of little utilities together. I wanted to get my data in as fast as possible, writing as little code as possible. And the last stage in this Unix pipeline, more or less, is Mongo import. It works on JSON. I figured this would be a great approach. So we have most of the components together, run Mongo import on this the first time, and first problem I run into is what they say is JSON on this export utility actually isn't. So this is what it's outputting. This is on one single line. So time isn't actually a time. It's not a quoted string. It's not a JSON date format. There's no commas, so there's the SCM internal document. There's no commas in there. There's really weird white space in places, so it looks like JSON. It really isn't. I mean, someone just put together an sprintf and called it JSON. So I had to go back and convert it to actual JSON Mongo import could use. And this is an eye chart of the massive regular expression pile that I threw together that tried to do this. It actually works. I used it the other day just to make sure my recollection is still good. It works, it's slow, but I didn't care at the time. So after you run it through that, this would all be on one line, but I basically cleaned everything up, got rid of all the white space, lowercase some of the fields, put in JSON date format, so I actually get a date time object. So going back to my plan, now I have to clean my data. Not a lot of fun, but hey, regular expressions. And then dump that into Mongo import. Kind of worked. Ran into another problem. So this is this is part of how the meters actually work, is they're constantly sending out what the utilization is, even if it didn't change. So as you can see here, we have 615, 621, and then a bunch of duplicates. And they do this because they want the truck to pick up a signal, even if nothing has changed. For all intents and purposes, I don't care what it was or how long it was. I can figure that out when it changes next. So I have just tons and tons of redundant data here. So going back to our plan, we have to clean up the data, import it, and do the deduplication at the end. So it works. Nothing surprising there, but it's really, really, really slow. This whole process is taking me overnight. I timed it later. It's roughly 4-ish hours. I'm reading 10.5 gig, inserting roughly 91 million documents. Most people would have given up there, but I'm a performance engineer. I'm not going to let this stand. So besides that, besides being slow, we had a couple other problems here. So queries are kind of a pain to work with on tabular data for time series. So if I wanted to figure out what my utility bill was going to be, what I had to do was go out, figure out what the meter ID was, figure out what the earliest reading was before my time period, do the opposite of that, get the reading after my time period, then I can delta the consumptions. Could do this kind of with aggregation. It's not really a great match. The 4.0 date operators add a little bit to this, would make it a little easier. I started this well before 4.0 was actually a thing. The other problem I ran into quickly using the previous approach is I was missing data. So sometimes I just didn't get readings. It's wireless, maybe something happened. Occasionally, like my house would have a power outage. My little reader would be gone. Maybe I rebooted to update the operating system or something like that. And I quickly learned, especially on the very fine grain, like looking at an hour, if it was off for 1 or 2 hours, well, my consumption is going to be really big. I have a time series of missing data for both ends that's going to be much larger than what I'm looking at. So that really didn't help me at all either. The other problem I ran into was trying to display the data. I have this little display. My idea was I was going to put this in my kitchen. It's about 3 inches across. I just wanted like a bar graph, show what my utilization over the last 24 hours, binned by hour. Show, what I was actually doing, what the what my utilization actually was. Maybe this would switch between different graphs. And this is on a really low power, Wi-Fi device. I didn't have a lot of, I couldn't really go to the database a lot. I wanted to generate this pretty quickly. I had to write in C++, that was gonna be a pain. So trying to do that binning with tabular data is also a pain. So you have to do the same kind of thing, get the before, so you have a point that you can actually run off of, and then you do a find, you get your ID, then you do a greater than find. So you're getting 24 hours worth of readings, pull that all in, then you have to iterate through and manually bin all the data. So you say, did the hour change? Yes, then push out the last hour. So at the end of this little process, you have 24 hourly readings, and then you can figure out what your consumption is and make a graph. I didn't really want to do this. This was a lot of work to do on a low-powered, Arduino type device. So to recap all of the problems I had with this approach. So pain to clean the data. I like regular expressions. They're not very easy to use, not very fast. I had duplicate data I was trying to remove later. All of my queries were a pain, dailies, weeklies, things like that. This was really slow process. It was taking me 4 hours. Didn't really like this process at all. I'm like, well, I don't like how long this is taking. I'm gonna ignore all the other problems for now. But I'm just gonna go out and I'm gonna rewrite this. I had been avoiding this forever. I'm like, I really just wanna look at the data. I don't wanna write my own ETL tool. So I'm like, fine, I'm gonna do it in Go. Seems like a good choice. I get multiple Go routines so I can split up my insertion load. That should make a performance difference. I can do this in parallel, so I can take advantage of all the cores on my laptop. I can do lots of batch insertion. I can do a much cleaner data process where I'm cleaning up and making documents. So this made a lot of sense. So, spent an afternoon, rewrote the whole thing so I could replace my regular expressions, Mongo import, all of that with just a Go tool. So it looks something like this. So I'm reading my 10.5 gig file, clean up everything so it actually looks, so it's in a format I can convert into a document, convert it to a document, then I just send all these 91 million documents off to round robin them between insertion workers. So, spent an afternoon doing this, everything looked great, code looked clean, and it really didn't change the performance that much. I'm like, this is still taking overnight. This is way too long. So finally I take a step back. I'm like, okay, where am I spending all of my time? So once you look at the actual run times, which I should have done a little sooner, I'm seeing that, well, the cleaning stage, so my giant regex, and the Mongo import is only 25 and 14 minutes, respectively. So I can eliminate a lot of that with my own tool, but I'm still spending all of this time doing deduplication. So, well, that's not a great story. I should probably figure something out for deduplication. And this comes back to one of the themes here, where this is a problem with tabular data. This isn't a problem with MongoDB. MongoDB was being awesome at dealing with tabular data. I was importing it really quickly. I could query it really quickly. MongoDB was doing great at this, but this really didn't match my use case. It's showing the inherent pain dealing with this style of data. I did a lot of back and forth trying to figure out what I could do with this. And it really came down to this giant slide. I really needed to change the schema. What I was dealt with, the data I had, did not match the data that I needed. I needed to do something to better represent what I wanted to do with my data. And that's really the power here, is thinking about what you want your data to be, not what your data is. So this was going to be a lot more work. I needed to do a lot more work on my ETL tool. I had to figure out what schema I wanted it to be like. I spent a very long time talking to a lot of schema design experts and trying to figure out what my use cases were. And finally, I settled on this new schema. This has pretty much been what I've stuck with ever since then. This is a very high-level view. I'll dig into this a little bit. So the big key here is I'm doing one document per hour. So instead of doing a single document for every single reading, your standard tabular model, I was going to bin all of my data. So every hour, I insert a new document. As reading comes in, I update the readings array. It allows me to do a very easy cutoff for insertion. I know if I'm doing my ETL for 10.5 gig, as soon as the hour changes, I'm allowed to go insert that. I don't have to wait for anything else to come in. This also allows me to do all my duplication ahead of time. I don't have to store redundant readings. I'm also storing the before and after, so I can automatically get the consumption. I can linearly interpolate my consumption, so I know exactly at 00 when the hour changes over what my reading should have been, even if I have incomplete data. Maybe the reading was a few minutes or a few hours behind. I should have a very good marker for that. I'm also embedding the readings, as I mentioned. If we want to go back later and look at a more granular level than a single hour, I can still do that. I can do a projection or unwind this array. I could do any, look at them individually. So this, I'm not losing any data by going to the hour method, but I get a lot of advantages. I'm also storing a delta between the previous hour, so that makes future work a lot easier. The other thing I did was split out time. 4.0 releases a few more data operators that I didn't have available beforehand. So basically, I take the actual date, I split out the hour, so that's 1 through 24. I have a weekday, I have the day of the month, I have the actual month and the year. This allows me to query it a lot easier. I can do much easier queries on my little device. And it also lets me use Compass very easily on this. I get a graph showing exactly how my days lay out, how many readings per day I have. So if I want to dig into a certain day or hour, I can just click this in Compass and it will just drill in exactly to the exact data I want to look at. Consumption is also a lot easier. I have all these convenient fields I can query on now. So now I grab the year, I grab the month, I grab the day. That's everything I need to do to get all of the hours for that day. I can then do a simple aggregation with a group, sum the consumption, boom, I have the exact reading for a 24-hour period. I can also do my 24-hour graph in a single query. Same thing, consumption, the date. I'm sorting, so everything is aligned by the date. I'm only getting 24 of them, get an array of it. That's all I need to do on my little device for binning this data and displaying. So now that I have this ETL tool, I fixed all of my problems. I can clean my data really quickly. I don't have any duplicates. All of my queries are now super easy to do, and it's fast. And you're gonna ask how fast? So it was taking 4 hours, and now it's taking 3 minutes. So huge change in performance. And that goes to the key point here, which is changing the schema out was the single biggest performance win out of everything that I did. I did tons and tons of optimizations on this, but going to the binning model where I had a document per hour really was the single biggest thing that enabled all of the other performance optimizations. So by the numbers, I went from about 4 hours to 3 minutes. So took about 202 minutes away from deduplication. The data cleaning, I took 24 minutes off. Parallel insertion took about 11 minutes, so I was doing better than Mongo import by 11 minutes. I also greatly reduced the number of documents. So instead of 91 million, I'm down to 400,000 readings, and then 91 million documents to 31,000 documents. because the readings are embedded in the documents. And if you multiply by 2, that's roughly the number of hours between 2015 and today. My original file, which is still there, is 10.6 gig of JSON-looking data. And now, once I import that, it's only 13 meg, 31 meg uncompressed in WireTiger. So everyone's going to ask, because the title, how did I get from 3 minutes to 60 seconds? And this is where I get to show off a little bit. These are all the cool things that I did to get from here to there. So buffered input really heavily. I was doing everything on a pipeline. I didn't ever want to wait for data to be available to me before I inserted it. I could do really simple checks to avoid stripping white space. It's relatively expensive to strip white space on 10.5 gig of data, so I could just look at various characters and guess if I needed to remove it or not. Removed all of my regular expressions, went to fixed string parsing. It fit on a line. I knew exactly where all of the boundaries were, so I could do that pretty easily. Tuning batch sizes, so I'm doing batch insert. So I'm inserting 1,000 documents at a time. So trying to figure out what the right number of documents to insert, that really helped me out in getting the performance up. Another thing I did was, kind of proactively, was optimistically encode all of my documents. So when you're storing a document in whatever programming language you have, it's storing it in that programming language's native format. So in Go, this would be a struct, is what I was using. So in order to actually get it to the database, you have to encode it. So there's the driver does this automatically when you pass in a struct, but you can also go and do this ahead of time. So that's what I did to crank up the performance, as I went and encoded the document before I tried to insert it. Because it was a pretty long time frame, this increased my insertion speed. Then my final optimization was batching on Golang channels. I noticed I was spending a lot of time in the Go scheduler, so there's a lot of overhead, moving things around, trying to figure out what worker could bring this data in for insertion. So, of course, there's a caveat. So I made the trade-off between solid engineering for somewhat fragile performance optimizations. So I started out at 4 hours. I did the redesign. Schema made a really big difference. That got me the majority of my performance win here. And then as I did the previous optimizations that I pointed out, it slowly took longer and longer. A lot more code I had to write. It was a lot more complex. It was a lot harder. It was not easy to translate into other things. A lot of people would throw up their hands and say, 3 minutes is good enough. I'm a performance guy, I can't let it sit. So no performance talk would be complete without a flame graph. This is Brendan Gregg's favorite data visualization for performance. So this is the best graph I could find that would show what I was actually doing before. So this is the 4-ish hour case. So before, this is the entire, regular expression. So my giant script that I ran ahead of time, a lot of time doing that. Over here, this is Mongo import. That's all the time I spent actually importing. And then this is deduplication. And if you look, this does not look 202 minutes wide. And that's really one of the key pieces is we spent a lot of time waiting. If we're waiting, it's not going to show up on this graph. So it was just all of the time going back and forth to the database that was adding up to 202 minutes. So after everything is one program now, I have one little ETL tool written in Go. This is what it looks like. So this entire span is 60 seconds. So over here, this is the only time this little graph or this little selection on the left and the right is the only time I'm actually doing anything. So this is only about 25% of the time. And then the rest of the time is spent actually reading the file. Reading 10.5 gig takes a while no matter how fast your system is. I'm doing a little time over here on garbage collection, and the Go scheduler is taking the rest of it. So my key takeaways here, make sure you follow best practices. We do our best to try and teach everyone about this. Batching your writes reduces those round trips to the database, really helps out the overall performance. Do lots of workers. You don't want to be waiting on any one thing to come back from the database. You want to parallelize as much as you can. Make sure you're designing your schema based on what the data you want is, not the data you have. Of course, make sure you understand the big picture. This would have been a much shorter talk if I did that ahead of time. You can treat database performance questions just like any other software issue. And tabular data really isn't a great way to represent many problems. So the whole purpose of this was to learn what I was doing with my energy and water consumption. So I thought I'd include that here too. My key takeaway here was my household consumes a ton of water. I changed out all my shower heads, saved 30% on my water bill every month. Changed out my water heaters, saved $50 in electric. I went from an electric to a gas water heater. And then the really interesting one was there was a very high correlation between when certain people were home and what my energy consumption was. So I went and replaced a whole lot of light bulbs in the rooms they only used. I would do things like proactively go and shut off their 3D printers. I did a lot of things like that too, and that really cut down my energy bill. So in conclusion, I just wanted to say the document model was really the key piece here. This really helped me unleash the potential performance I could get out of this and really helped me get the insights I wanted to learn from my data. So as kind of a final thought, I wanted to implore all of you, we have all of this cool data, some of it's floating in the air around our heads. Just go out. Maybe you can use it to learn something cool or learn something cool about yourself. Thanks.
So we do, I know people are going to start jumping out of the room. We do have a couple minutes for Q&A if anybody has questions for Kevin. We have 5 minutes for Q&A, which means you have 5 minutes more to make it to the next thing, which means you don't need to rush out yet. Any questions? Do people want to know who it was in the family causing the high spikes in usage? Is that the big question?
Everyone always asks.
They haven't asked. Nobody wants to ask a question.
Nobody wants to know?
There may or may not be, there may or may not be a huge prize for asking a question. I said may or may not be. There isn't one. But I'd still like you to ask a question.
I would like to know who the users were.
It was actually my brother. He was living in my basement for 2 years because he's a roadie and was on tour with AC/DC on and off. He has a 3D printer. He has a rack of high-end lighting and audio gear that he would run when he was home. So there was a huge, tripling of my electric bill. So
I don't want to sound weird on this one, Kevin, but if you needed this whole system to figure out that's where your bill was coming from, you should have spent more time in the basement.
Yeah. So the answer is I kicked him out. He now owns his own house, so he can pay his own bills now.
Sorry. Okay, we got a question over here. Do you want to shout it or you want the mic? Let's try the mic, because I think we're recording this too.
I'm not super familiar with the appropriate strategies, but since you are the expert in the field,
Yeah.
you've got a trade-off between batch size and number of workers.
Yes.
And sort of how is the sort of methodology, in a brief answer, I'm sure this could go way deep, but
Yeah, so
how do we get to the sort of correct settings in that area?
Yeah, so I basically just did it, I just kept testing it. So I just went through and I'm like, well, what happens if I half it? What happens if I double it? The big thing is, my laptop only has so many cores, so that's kind of where it ended up. It was about 8 workers, seemed to be about the right place for me. And that's running both MongoDB and my loader on the same machine. So MongoDB has a bunch of threads it's running as well.
We had a question. Was that you?
Just wondering, is it a same collection where you are inserting all of your documents, or a different collection per hour or something?
So it's one collection with all of the documents in it. So all of the hours are in the same collection.
You keep the history as well on a same collection? I
Yes.
mean, like years worth of data?
Yeah, everything from 2015 to now is in the same collection. And that's just the way it happened to be very easy to do it. There's no real reason not to go to multiple collections, or you could make whatever trade-off you wanted. It just worked really well, and then I can use like Compass to like bin up which meter I want to look at or what year. So the amount of data works out really well for that, at least in my case.
All right, thank you.
All right, we got time for one more question. And if nobody has one, you have to listen to me talk.
When you mentioned the deduplication that you were doing, was that done by Mongo itself? Did you get the duplicate data into Mongo and then deduplicate, or did you deduplicate before you went in?
So I tried both approaches. So I tried deduplicating before I went in, and that was kind of at least the paths I went down were dead ends pretty quickly. So the path I ended up taking was just put it all in Mongo and then deduplicate it later. So that was the easiest approach. In hindsight, that probably wasn't the best approach, because deduplicating schema changes really made a big performance difference. So